right, dear students, dear friends. In this video, we will be discussing the pulley problem. We will be applying Newton's second law of motion to a frictionless pulley, and you can see on the board there is a diagram. There's a pulley, and there are two masses, capital mass and small mass, and this capital M is greater than that of the small mass. Now what we are interested in this problem is we want to calculate the acceleration with which this system will move, and we want to calculate the tension in the connecting strings. Now what we assume here is that these strings are inextensible. That means they cannot be extended by virtue of any force, and we have this pulley does not provide any kind of opposition to the motion that is available here. Now we would like to solve this problem, and we would like to calculate the acceleration, and we would like to calculate the tension in the string. Now to start with, it must be quite clear that I'm assuming that this capital M is greater than that of small m. That means this system can be assumed to be moving in this direction. So let me draw some vectors. On this body there will be the gravitational force acting on it, that will be mg, and on this there will be gravitational force acting on it, that will be mg. In this case the tension will be in the upward side. Similarly, the tension in this case will be in the upward side. Let me assume that tension is T. That tension is T. Alright. So if I assume that this motion is in this direction, that means I will say from this side the acceleration of the system is downwards, and for this side the acceleration should be upwards. So let us take on this side of the problem and write down Newton's second law of motion. Write down the net force acting on the system. Okay, now you see what's happening in this case is this body is moving in, we're assuming that it's moving in downward direction. So if I take on the case 1, I will have mg. Okay, this mg is opposing the tension minus T. It must be equal to the net force. That net force will be MA. This I will call as equation 1. Now let me go with case 2. Now let me go from this side. Now from this side what we are assuming that this system is going up. This mass is going up. So T must be greater than mg. So T minus mg must be equal to ma. Okay, so we have write down the equations, the equation of motion for both the sides of this problem. Now let me add these two equations. So adding 1 and 2. Okay, if I add these two equations, you can see that this T will cancel out. And what we will get? We will get mg minus mg is equal to m, this is capital M, plus m small m into A. So from here, we can calculate the acceleration. So what will be the acceleration with which this system will move? That will be m minus m times g divided by m plus m. This will be the expression for acceleration. So this expression will give me the measure of the acceleration with which this whole system is going to move. Now at the same time, I want to calculate the tension in the string. So I can use the value of this acceleration in any of the two equations of motion that we have written down. So suppose I use this value of A in this equation. Okay, so T is there, minus mg is there, is equal to m. A. Instead of this A, I will write this. What is this? This is m minus m divided by m plus m times g. So what will be T equal to? T will be, okay, this is m minus, this is m squared. Alright, this is, can do it that way also. Okay, this mg, this is m times m minus m divided by m plus m times g plus mg. So T will be, what will be common out of here will be mg will be common. So this will be m minus m divided by m plus m plus m plus 1. Okay, here I will have m plus m. Here I will have m minus m plus m and plus m. This m and m will cancel. So this is mg from outside. So we will get the final expression for the tension, by virtue of which we can calculate the tension in the string. So what will be that? T will be equal to m g. Okay, this is mg. This is m into m. This is m plus m. This is 2m times 2m. Sorry, this is capital M here. Divide by m plus m. So the tension in the string will be twice m mg divided by m plus m. So this equation will give us the measure of tension in the string.